Now we're going to take a look at actually finding formulas for inverse functions. So let's start with an example. Suppose we know a car travels 65 miles per hour. Then we could actually say the distance it travels as a function of time is equal to 65 times the time, right? If you're traveling 65 miles an hour, you drive for 1 hour, you're going to go 65 miles. If you do 2 hours, it'll be 65 times 2. 3 hours, 65 times 3, and so on. So d is going to equal 65t. Now suppose I wanted to take my d equals 65t and I wanted to get the opposite situation. Instead of having the input of the time, suppose my input was the distance, right? So now I'd like to say, okay, if I need to travel 300 miles, how long will that take me? So now instead of distance is a function of time, what I would like is time is some sort of a function. I'm going to use a different letter. Suppose I'd like time, I'll use big F, is a function of distance. So I'd like to have that relationship. Well, the way I could do that using my original function d equals 65t is I can just solve for the t variable. And that's all I'm going to do. To get the inverse, I'll just solve for t, and I get t equals 65, t equals d over 65, say it in the right order. So all we did was solve for the other variable. In this section, that's all we're going to do to find the inverse. We're going to be dealing with functions that have meaning, and when we have a function that has meaning, when there's a story behind it, what we're going to do to find the inverse is just solve for the other variable. So we're going to solve for the previous dependent variable. Some of you may recall doing inverses in previous math classes where you switch the x and the y and then you solve for the new y. We're going to do that, but not until the next section, and we will only do that process when we have a function that does not have meaning. If the function has meaning, if there's a story behind it, we are going to just solve for the other variable. So if the function has meaning, the variables represent some sort of physical quantity, we're going to just solve for the previous independent variable. So we're going to have a just rewritten function. And you've done this tons of times in your mathematical history. We just didn't talk about finding the inverse. So here's an example. Suppose we go back to our old Celsius Fahrenheit example. C, to get the Celsius, is 5/9 the quantity Fahrenheit temperature minus 32. This has a story. This is the function that converts from Fahrenheit to Celsius. What I'd like to do is find a formula for the inverse function. Since it has meaning, all we do is take this function, solve for the other variable. And so I did that here. I had C equals 5/9 the quantity F minus 32, and I chose to first get rid of the 5/9. You might choose to first multiply through by the 5/9, but I said I'm going to get rid of the 5/9. So to do that, I'm going to multiply both sides by 9/5, which I did. So that gives me 9/5 C equals 9/5 the quantity 5/9 multiplied by the quantity F minus 32. And then, of course, when we do this, the 9/5 and the 5/9 cancel out. So we have 9/5 C equals F minus 32. To solve for F, we get F is 9/5 C plus 32. This is our inverse. That's all there is to it. Do not interchange the variables. Just solve for the other variable. It has meaning. It's very simple. Just do the algebra.